Welcome to the part 4 of our security lab. Now this is the fourth part of our security lab using Apigee X and having comprehensive security. I have taken it straight out of as a preview lectures number 4 from my just to be released enterprise API management using Apigee X course, and I strongly recommend you to enroll in that course, and I'll be giving you the promotional coupons on receiving from you as a comment. We will be implementing the strongest form of transport level security, which is called mTLS or Mutual TLS. In a modern Apigee environment, this isn't configured inside Apigee itself, but at the network edge. That is the power of using Google Cloud Load Balancer. So you'll be using Load Balancer, which is a new technique. So stay tuned and see the entire video to get the knowledge that you'd love, okay, and that will come handy in your practical production environment too. This module will walk you through the real world process, simulating the distinct roles of an API developer and a cloud network administrator. Before we dive in, it's crucial to understand the architecture. Client traffic doesn't go straight to the Apigee runtime. Okay, rather than that, it is intercepted by the cloud load balancer. This load balancer is responsible for the entire TLS or transport layer security handshake, including the critical step of validating the client certificate. And this fact represents a major architectural shift, moving the security function away from the Apigee to the broader cloud network layer, which provides global scale and centralized control. So, what are the lab roles and responsibilities? To simulate a real enterprise environment, we will be playing two roles. First, the API developer, whose job is to create the client-side credentials, the key and certificate, and later test the connection. Second, the cloud network admin, who is responsible for the powerful backend configuration, managing the trusted certificates, and programming the load balancer or configuring the load balancer to enforce our security policy. So let's move on to the next slide, which is about the first step for the API developer, which is on the client side. Our first hands-on step on the actual Google Cloud Console. In a bit, we will be doing that, is the API developer. Now, the goal is to create a key and a public certificate. So we need credentials. So using the standard Open SSL tool, we'll run two commands. Now, before I run these two commands, I will tell you how to, from where to install Open SSL if you haven't got it installed, downloaded and installed, because I have also not installed on this machine. So I will also run you through this exact thing, how to install. So we'll open this website, slproweb.com/products win32 OpenSSL. Now there are a few versions for Win64. There is this light version on top. So this is the one I would prefer to install, because this is where I tested, and this you don't need the higher memory usage. The full version, it is good enough to use the light for this lab. Okay, so you click the exe and it has been downloaded. I will get back to that. So on my machine it is downloaded, the exe file is downloaded, and it is telling Windows protected your PC, don't run, and I'll click on more info and run anyway. Yes. So it asks for your permission. I said yes, and I accept the agreement, whatever it is, license agreement. Click on next, and I will let it install on my default path, which is my C drive program file. You can change this, of course. And open SSL, select start menu folder, and I will go for the default and click on next, click on install, and it will install, and click on finish. If you want to give them donation because it is an open source project, you can, but I wish to finish it. Now I open it on my machine, and it gives me this command prompt, Win64 OpenSSL command prompt, and it is getting a default directory. Now the first thing is to verify your installation. So I give this command OpenSSL version, and it gave me this version. Now I am ready to proceed further with this lab. So I take it, I will just minimize this and get back to my slideshow for the next step. Okay, and these are the commands. So these commands, create the private key, first command, OpenSSL gen RSA out client.key 2048. It's all in the lab guide. And then create the public certificate from the key. All right. So here the outcome will be client key and client certificate shared with the admin. All right. So we will get there with the OpenSSL. So next I issue this command on OpenSSL command prompt, and then it has already created it. I will just bear with me. I will just verify its creation, and then I go to the next command. So this is to create the client certificate from the client key. We are entering the key whichever is created on this directory. Okay, for me it is C users David. So you are about to be asked to enter information that will be incorporated. Now this is important to know. So country name, 2-letter code, mine is New Zealand, so I write NZ. Now it's not necessary to fill on all the steps. You can get away without filling a few. It's optional. And locality name also, it's not necessary. You can just skip it. Organization name, if you have an organization name, you can fix it. So this is also optional, so I skip that. You can of course put a name. And organizational unit name also is not important. Common name is most important. I'll put it security test app client. You can put any other one. And why it is required? The common name is the primary field used to identify the certificate's owner. While OpenSSL might let you proceed without it, the resulting certificate will be practically useless because it would have no identity. This is the common name, which is the most important. So if you hit enter, email address also you may skip. So it's all done. Okay. So in a bit I will show you. So you can see that I have browsed to my directory where they were created, client.certificate, client.key. So it's all created successfully. So next step or step 2 will be the cloud admin or the service side. So we'll have to create a trust config. So navigate to certificate manager, trust configs, which I will do, and create mTLS trust config and upload the developers client.cert. Okay. So we'll all do it practically on the Google Cloud Console. So on the Google Cloud Console, I will type certificate manager. Certificate manager automatically comes. All right. So you can see clearly trust configs is there. Select a project. Okay. I have only one project, certificate manager for Apigee Dev course project, trust config. So add trust config and follow our PDF lab guide for this. So as per my PDF lab, I give it a name, mTLS trust config, no description, it's not needed, global, and trust store. So add trust anchor, I have to click on this link, and then I will have to upload. This is the crucial step here. So if you look into our PDF guide, you'll see that you'll have to upload the client certificate file provided by the API developer. Okay, so I am now working as a network administrator. I am no more, my role has changed from the API developer, and it's still me, but I am working as a network administrator. So I click on the upload, and browse to where my client certificate is there, which is C users. If you remember, it will be different from you. David and date modified client certificate. Okay, so client certificate is already loaded, and then click on add. Great, it is already there. Okay, add trust anchor. Although it doesn't show over here, but I have already successfully added it, and I'll click on create. So you can see that mTLS trust config is already created. So more options, of course, you can delete or edit it. Now the next step. So create an SSL policy. Navigate to network security, SSL policies, and create a global policy name mTLS enforcement policy. Okay, so create an SSL policy. Back to our certificate manager portal on Google Cloud, I will just click on Google Cloud, and now this time I will look for navigate for SSL policies. So automatically SSL policies come. SSL policies, I will click on it. So it gives me create policy feature. Okay, let's create policy. Now this will be a global SSL policy. Okay. Again, looking back into my guide, the name that I have chosen is mTLS enforcement policy. Just like we created the trust config and we named it mTLS trust config, now we name it as mTLS enforcement policy. No description is needed, and minimum TLS version is 1.2, the latest one. Okay, and then this profile. So profile out of these available, either modern or restricted. So wide set of clients or restricted, reduced, both of will do. Okay, for this lab, let's click on modern for that timing. And if we click to apply to targets, I will get this one. Apply to target. The only target is our Apigee proxy HTTPS LB rule at my IP address that has been fixed by Apigee runtime for that eval organization. So I'll click on OK and click on create. OK and create. Make sure this is included in the drop down list. So mTLS enforcement policy is already created. Now let's see, apply configuration via Cloud Shell. Use G Cloud to update the Apigee proxy, HTTPS proxy to use the new SSL policy. Okay, so what we did, just for a revision, we configured the backend. First, we created the trust config by going to the certificate manager, and this is our modern trust store, trust config, and here we'll upload the developer's client certificate to mark it as trusted, so which we did. Okay. Secondly, we went to the SSL policies and created a global policy that was to be eventually used to enforce our rules. Finally, because the UI for the Apigee managed load balancer is logged, we will open a Cloud Shell and running gcloud command to programmatically attach our new SSL policy to the target proxy, activating our configuration. So we'll go back to our Cloud Shell, our Cloud Console Cloud. I have clicked Google Cloud, and this search bar, I'll have to search for load balancing. Load balancing. Click on load balancing. Okay. Now on my load balancers page, I see this is the default load balancer Apigee proxy URL map. Here there is a link which says that to view or delete load balancing resources like forwarding rules and target proxies, go to load balancing components view, which is this view, load balancing component view. So I click the target proxies. Okay, so the Apigee proxy, HTTPS proxy is already there with this target, and when I click this, this will give you this gives me the target proxy details. Okay, now here I see that there is no edit button over here. I cannot do, so I will do the editing through a bash command on the Google Cloud with the gcloud command on the Google Cloud shell by activating the Google Cloud shell. Okay, so I will do what I will do is you're already familiar with how to activate Google Cloud shell. Once more, I will activate it and come back. So on the Google Cloud shell, I give this command, which is also in your PDF lab guide. Could not fetch resources. Okay, Apigee proxy was not found. Let us see. I will come back. Now the error that we got here, gcloud target HTTPS proxies update could not fetch this resource because this was wrongly spelled. Okay, so to get the right spelling, I gave this command gcloud compute target HTTPS proxies list. So in the list I found this name, and now I corrected this gcloud command with this name. You can see that here is a hyphen which was missing. There was no hyphen over there. So I corrected this, and let's click on enter. So after a few seconds, it has updated it. Okay, so it has finally updated it with this gcloud command, which is now correct. Okay, so let's move on to our next step. Now the final step. This is the final step, which is testing. Okay, so with the configuration live, we switch back to the API developer role for the final test. To avoid any local machine issues, we do it from the Cloud shell after uploading our key and certificate. Okay, and the first test will be a test of failure because we will not include any certificate. As you can see, it fails instantly during the TLS handshake. It's rejected at the front door, you can say. Now we run the command again, but with certificate, and that will come later. So let us get back to our Cloud shell. Okay, now here I will have to upload, before these two final tests, I'll have to upload my certificate. So I will click on these three dots, vertical dots, click on upload, and choose files for my machine. Okay, so I'll browse. So this is choose files. It will take me to my file explorer or Windows Explorer, whatever you say. So see users. Now again go to users and David, and client certificate and client key both have to be chosen. All right, choose files. Okay, click on open and then upload. It is uploading, you can see. Now these two files are successfully uploaded, the certificate and the key. I'll just close this, and we are now ready for the final tests. So as discussed previously, I gave the first test, which is a failure test, and you get this answer. 401 error is there, HTTP2. Okay, it's 401 error is there. All right, now we'll go for the success test, or test that should pass. Okay, so now I have got the success test also. So it is all successful. See, I have given the client key and client certificate. to my IP host IP address /version1/security-lab get, and I've got this 200 OK success. So I can run it once more. Just clear it. And this is on my clipboard. Paste as plain text. It should be on one line. That's how the curl is successful in the first attempt if you write the full command in one line. Okay, so you got the success again. So this is the response from the server, and previously HTTP to 200. Okay, so this confirms the entire end-to-end flow is working perfectly, and we are an expert already in advanced security on Apigee X.